In this video, we will discuss an example of finding the Laplace transform of a piecewise-defined function. As you may recall, a piecewise-defined function is a function that is defined differently at different domains. So for instance, if you have here a function f of t equal to 1 when t is from 0 to 2, and t minus 2 when t is greater than or equal to 2, then you have here a piecewise-defined function. So getting the Laplace transform of this kind of function, we can use the same method, okay, which is by definition. Now recall that Laplace transform of a function f of t is equal to the integral from 0 to infinity of e to the negative st times f of t dt. Ang problema natin dito sa given natin is because it is not only a single function f of t, then we cannot just find the integral from 0 to infinity ng diretso. So what we will do is we will use a property of the definite integral. So if you may recall again, the integral from a to c of f of x dx is equal to the integral from a to b of f of x dx plus the integral from b to c of f of x dx. So pwede natin siyang putulin kung ang meron tayo ay putol na domain din. Just what we have in this piecewise-defined function. And so we can write the Laplace transform definition for this specific example as Laplace transform of f of t is equal to the integral from 0 to 2 of e to the negative st times 1 dt plus the integral from 2 to infinity of e to the negative st times t minus 2 dt. So in this case, kailangan lang natin kuhanin yung definite integral nito and then this one. Okay, let's separate this into two terms, no, a and b. In such case, we'll just integrate separately and then combine na lang later on. So we start with getting the integrals for letter a. Integral from 0 to 2 of e to the negative st dt. Now this is just straightforward. We know that the integral of e to the negative st dt will be negative 1 over s e to the negative st. So hindi natin kailangan pakita yung substitution kasi lagi naman natin yung nakikitang sa integration natin, no? Pag by definition, we always encounter this. So memorize nyo na yung i-memorize nyo na yung integral ng e to the negative st. So again, that's negative 1 over s e to the negative st evaluated from 0 to 2. So you will have here negative 1 over s times, evaluate natin si e to the negative st from 0 to 2. So upper limit first, negative s times 2 minus e negative s times 0. But this one goes to 1, and so you'll have here negative 1 over s times e to the negative 2s minus 1. So that's the integral of the first term. Now for the second term, we have the integral from 2 to infinity of e to the negative st times t minus t dt. So again, by definition, in evaluating an improper integral, we let infinity be equal to a, and so this integral from 2 to a of e to the negative st times t minus 2 dt, then afterwards we get the limit as a approaches infinity. Now in this case, we have to use integration by parts because we have a product of e to the negative st and t minus 2. Pwede natin i-distribute yung e to the negative st sa t minus 2, or pwede rin naman natin, which is mas madali, i-IBP natin ng buo. So we will let u be equal to yung t minus 2. So this will be our u, and then our du will be the e to the negative st, or dv rather, will be the e to the negative st, since yun yung alam na natin yung integral, and then yung t minus 2 we let as u kasi yun yung alam na natin mas simple yung derivative. So in that case, if we let u be equal to t minus 2, then du is equal to dt, and so dv is equal to e to the negative st dt, v is equal to negative 1 over s e to the negative st. Now, using integration by parts formula, the integral is equal to u times v. So, you'll have t minus 2 times negative 1 over s e to the negative st minus the integral of v du, negative 1 over s e to the negative st dt. So, we are just integrating first indefinitely. So, pag na-integrate natin indefinitely, tsaka natin siya i-evaluate from 2 to a. So, integrating further, you'll have here negative 1 over s times t minus 2 e to the negative st plus integral of 1 over s, or pwede natin ilabas yung 1 over s. So, you'll have plus 1 over s integral of e to the negative st dt, which is equal to negative 1 over s times t minus 2 e to the negative st plus 1 over s times negative 1 over s e to the negative st, yung integral ng e to the negative st. We can simplify this further by factoring out a common factor, kasi this one would be negative 1 t minus 2 e to the negative st minus 1 over s squared e to the negative st. So, pwede nating factor out ay negative 1 over s e to the negative st. And so, you'll have here t minus 2 plus 1 over s. And so, we will evaluate this from 2 to a, and then get the limit of that as a approaches infinity. Okay, so continuing our solution, so we'll just write limit as a approaches infinity of negative 1 over s e to the negative st times t minus 2 plus 1 over s, evaluated from 2 to a. Okay, so which gives us a limit as a approaches infinity of, so evaluate, okay, from 2 to a, so you have negative 1 over s e to the negative s times a minus 2 plus 1 over s minus negative 1 over s e to the negative s times 2 times 2 minus 2 plus 1 over s. So, this goes to 0. And then if you take the limit as a approaches infinity, you'll have negative 1 over s e to the negative s times infinity minus 2 plus 1 over s. And then you have here minus negative 1 over s e to the negative 2s times 1 over s. But since this is very large, it's negative, the value of e to the negative infinity is very small, so this goes to 0, and so this whole term here is 0. So what will be left will be positive 1 over s squared e to the negative 2s. So you'll have negative 1 over s times 1 over s, negative 1 over s squared, so may negative pa doon, so you'll have positive 1 over s squared times e to the negative 2s. So going back to our first term natin, so you'll have negative 1 over s times e to the negative 2s minus 1, that's the integral. Therefore, the Laplace transform of f of t is equal to negative 1 over s times e to the negative 2s minus 1 plus 1 over s squared e to the negative 2s.